Hey guys, today we're doing roots and radical expressions. So we're going to work on taking a bigger number and that is under a radical and breaking it down into its factors so that we can remove as much as we can of it from under the radical. All right, guys, so this is called roots and radical expressions. I want to talk about what a radical expression is or what a root is. The root is the answer to a radical expression. All right, hold on. All right, now my paper's straight. Is the camera straight? All right, so when you have something like this, right? So that's the radical sign equals the answer is the root, okay? So that's going to be the root. You are going to find the root when you simplify the expression, if it's a perfect square or cube or fourth root. If it's a perfect root, it will be, the answer will be a whole number. All right, and we have right here, that was supposed to be a different color. It's supposed to be purple. Right here we have what is called the degree. All right, so that is the degree of the radical. If there's no number there, it just means that the degree is 2 or a second degree radical, okay? This is the radical sign that I wrote in black, and then let's try to find a color that doesn't look black. That is the radicand. Okay, and degree is the same, right? That's the same word we were using for an exponent. Good. So when we say a radical expression, this is a radical expression. The root is the answer to the radical expression. All right. So you have the radical symbol for 1, 2, 3, 4, and 5. You have the radical symbol with no degree. If there's no degree, the degree is assumed to be 2. So for number 1, we're going to take 81. We put it under the radical expression. And right here we have no number, so we're going to assume that's the number 2. There's no number there, you can assume it's a 2, okay? So we want to take 81 and we want to find the root of 81. What can be multiplied by itself to get 81? I like to make a factor tree. So 81 is just 9 times 9. We know that, right? So the square root of 81 is also known as the square root of 9 times 9. If you have a pair, this is to the second power, so you need 2 of the same number multiplied by itself. 2 under the radical sign becomes 1 or itself outside the radical. Okay, you can also do this on your calculator. That just looks like that. Okay, or the square root of 9 times 9 is 9 because 81 is 9 times 9. Good. So the simplified expression of the square root of 81 is just 9. The square root of 64. Again, make a factor tree, which just means I take the number and I think of what 2 numbers can multiply to 64. So you could just start by dividing by 2. 64 divided by 2 is 32. So 32 times 2 will give me 64. 2 is now already in, that's a prime factor, right? That's as much as we can divide it by. We can't divide it by anything except itself. 32, we can divide by 2 again, right? So this would be like the slowest way to make a factor tree, but then that would be 2 times 16 gives me 32. And you'll notice that each layer of the factor tree, if I multiply those together, I get 64. 32 times 2 is 64. 16 times 2 times 2 is 64. And we can keep going, right? So 2 just comes down with it because it can't be factored any further. This 2 also comes down. 16, what do you think of? We can still keep dividing it by 2 and say 16 times 8, right? 8 times 2 times 2 times 2 is 64. 8 can become 2 times 4. That's still 64. And then 4 finally can be 2 times 2. So the prime factorization of 64 is 2 times 2 times 2 times 2 times 2 times 2, right? There are other ways to make the factor tree. You could say 64 is, right? 64 is just 8 times 8, because you know that. Or 64 is 16 times 4. And then 16 becomes 4 times 4 times 4, right? You can do it like that. And eventually that would give you 2, 2, 2, 2, 2, 2, 2 times 2 times 2 times 2 times 2 times 2, which is the same as 2 times 2 times 2 times 2 times 2 times 2. So there are different ways to write the square root of 64. You can just say is the square root of 8 times 8. Those two eights come out to give you 8, right? Or you could even say the square root of 64 is the square root of, right? Because if you factor it all the way down to its prime factorization is what this is called, you'll still get, you can write all of that as equal to 64. And I can just show you that that is true, right? And what were we doing over here? Because this is a known 2 right here, we're looking for pairs. So 2 9s come out as a 9. 2 8s come out as an 8. 2 2s come out as a 2. And then we have another pair of 2 2s. And another pair of 2 2s, right? So instead of the square root of 2 times 2 times 2 times 2 times 2 times 2, we have 2 times 2 times 2, which is the same as 8. Okay, so if you like factoring it all the way down to the smaller numbers and finding pairs of smaller numbers, that's also fine. Once you take them out and multiply them back together, you get the same as finding the bigger pair of numbers. Good. So the square root of 81 is 9. The square root of 64 is 8. What about 16? 16 we did over here, right? 16 is 4 times 4. And you could even go, so the square root of 16 we can say is the square root of 4 times 4, the square root of 2 times 2 times 2 times 2. This one, the pair of 4's come out. So the square root of 4 times 4 is just 4. Here, this pair of 2's come out. And this pair of 2's come out. And we get the answer of 2 times 2, right? Which is also 4. So the square root of 16 is 4, which is not quite what they give us, right? They give us the negative square root of 16. You just keep that negative out in front. So the negative square root of 16 is the negative 4. Good. The square root of negative 36. 36 is just 6 times 6, right? So the square root of negative 36, if we're not talking about imaginary numbers, which we are not today, we're not involving imaginary numbers, we're just going to say no solution. You cannot have a negative under the radical. So if you have a negative under the radical, you can just say no solution. Now, this is only true for a second degree, okay? Most of them that you'll see are second degrees. Here is a negative under a degree 3. That one does have an answer, okay? But I want you to think about a negative 36. So negative 36, how can we break it down? we can break it down into a -6 and a +6, right? Or we could break it down into a -2 and a +3 and a +3 and a +2, right? That would be the most factored form. There's still a negative, the negative end. So if I put it under here, 3 times 3 times -2 times 2, the 3 can come out, right? But -2 and 2 are not the same, so that would be just 3 square root and -4. But if they're asking you to take that -4, that -4 will not be able to come out, okay? So you can simplify it a little bit, but you'll never get that negative sign out from under the radical. So it'll never be a pair of negatives, right? Okay. Number 5, the square root of 0.25 is 0.5. Good. Okay. Now we have, instead of the degree being 2, we have a degree of 3. Good. All right. I said that if it's a degree 2, we say no solution when they ask us to simplify with a negative under it, or you can simplify it a little bit and leave the negative under it, but you can't get the negative out because there wouldn't be a pair of negatives, right? You can't get a pair of negatives to multiply to a -36. -6 times -6 gives you +36. -6 times regular 6 gives you -36, but those aren't a pair of the exact same number, right? Okay, when it comes to a third degree, that means we want 3 of the exact same term multiplied by itself, right? So 512. You can just say, what is 5 to the third? What is 5 times 5 times 5? What is 6 to the third? What is 4 to the third? Oh, it's not 4. 7 to the third. 8 to the third. You can even make a list or Google it. So the cubed root of 512 is 8. So the cubed root of -512 is going to be -8. Why can I take, why will it work with the third root and not the second root? Because a negative times a negative times a negative will make a negative, right? -8 times -8 times -8 does give me -512. Good. So if it's a third root, a fifth root, or a seventh root, any degrees, then you don't have to say no solution for the negative. You can find the real answer. And again, because this is raised to the third degree, you need 3 of the exact same term, and we have 3 -8s. So the cubed root of -512 is -8. The cubed root of 64, what do you think? We know that 64 is 8 times 8, right? That doesn't help us to find a cubed root, right? Because here we wanted 2 of the same number. 2 8s multiplied by themselves make 64. Here we need 3 of the same number. So 64, we said it becomes 8 times 8, right? Let's keep going in our factor tree. 8 becomes 2 times 4. So 64 is 8 times 8 equals 64. 2 times 4 times 2 times 4 equals 64. And we'll just we'll do one more layer of the factor tree. That 4 becomes 2 times 2, that 2, and then that 4 becomes 2 times 2. So 64 is 2 times 2 times 2 times 2 times 2 times 2. Why does this help us with this one? Because with this one, there's a 3 right here. Oh, sorry. So that means there should be a 3 right here. So that means we are looking for groups of 3 of the same number. 3 2s come out. 3 2s come out. So the cube root of 64 is 2 times 2 or 4. The 64 is not only 8 times 8, it's also 4 times 4 times 4. 4 to the power of 3 is 64. Just ways to check your answer. Cube root of 64 is 4. Okay. Simplify, assume all variables represent real numbers. So we have -9 squared. By order of operations, do you deal with the radical first or the exponent first, and why? So the radical is a grouping symbol, just like the parentheses, right? And according to PEMDAS, the order of operations is parentheses or grouping symbols, exponents, multiplication and division, addition and subtraction. Because the radical is a grouping symbol, we are going to deal with what is inside the radical first. Okay, so that doesn't mean that because this is a grouping symbol, we do it. Because it's a grouping symbol, we do everything inside of it first, right? So -9 squared, notice the parentheses, okay? Because if I do -9 squared, they're going to give me 81, -81. If I do parentheses -9 squared, they're going to give me 81. Okay, so do exactly as it's written on the website. Parentheses -9 squared means -9 times -9, right? Whereas -9 squared means -9 times 9. See the difference? All right. So we saw that -9 squared is 81. Good. And so the square root of -9 squared becomes the square root of 81. And what's the square root of 81? We did that as the first problem. That's 9. Good. So -9 squared, and then you take the square root, you get +9. The cubed root of -6 cubed. So again, this is a grouping symbol. We're going to do everything under it first. -6 to the power of 3. If I just spread it out, it's just -6 times itself 3 times. Good. -216 if you want to, or we know that if we see 3 like this under, sorry, I always forget this. I hope that's not too confusing. If you see 3 of the same thing under a radical symbol with a degree of 3, that means we take it out, and it's just -3 is our answer. But you can also multiply it together. -6 cubed is -216, and then you take the cubed root of -216, and you get -6. Oh, why did I write -3? Guys, I'm supposed to teach you, and all I do is confuse. Good? All right. So either way you do that, just remember to do under the radical as simplified as you can before you take it out of the radical. And this is taking it out of the radical. Good? All right. Number 10, simplify the expression and assume that all variables are positive when they appear. So the fourth root of 16, we know that 16, right? 16 is 4 times 4. 4 times 4 becomes 2 times 2. So 16 is just 2 times 2 times 2 times 2, right? Look, I remembered this time. Put the 4 up there. So I'm looking for 4 of the same exact kind multiplied by itself. 2 times 2 times 2 times 2 is 2. Good? All right. The fourth root of 81 is 81. And you can obviously always do this with your calculator. This is just how I got to it, right? 81 we know is 9 times 9. And then can we simplify 9? Yes, 9 also happens to be a perfect square of 3 times 3. So 81 is 9 times 9. 81 is also 3 times 3 times 3 times 3. So the fourth root of 81 is the same as the fourth root of 3 times 3 times 3 times 3, which is 3 as my final answer. Good. All right. Now let's talk about simplifying radicals containing variables. If you need to change from a radical to an exponent, you can turn that exponent into a fraction, okay? Okay, so what you should see when you look at this is that, and I'm going to write it up here, x to the power of a over n, the fraction, okay, becomes x is now the radicand, so x is now under the radical sign. So same base is still now under the radical sign. Good. The denominator, the n, is now your index or your degree. So that's now that. Okay. That became that. And the a is the power of that same base. Okay. So the numerator becomes your exponent. The denominator becomes your degree. Good. Okay. Recall that x to the power of a with an index of n is equal to x to the power of a divided by n, which means for variables, you are basically dividing the inside exponent by the root, okay? Any whole number part comes out of the radical while the remainder stays inside. So y to the power of 7 taken to, with a radical expression taken to the third root is y to the power of 7 divided by 3. So we took 7, made it the numerator, and that 3 from the outside is the denominator. Good. Now, since 7 over 3 is 2 remainder 1, y to the power of 7 over 3 is y squared times the cube root of y. Good? All right. You can also just write it all out. So we're going to simplify 9 times y to the 8th. There's a 2 right here, right? Because there's no number. So we assume it's a 2. 9 is 3 times 3. Y to the 8th means there's 8 y's. Good. That means I can take out a pair of 3's and 4 pairs of y's, right? So that becomes 3 3y to the 4th, or if you like dividing, right? We can also say the square root of y to the 8th is the same as y to the power of 8 over 2. So we took that number, put it here. We put that number in it here. 8 divided by 2 is 4. So either way, you get y to the 4th. Sorry. And I just ignored the 9, right? I was just doing the variable. Good? Okay, so here we can take 12 divided by 3, 12 divided by 3. So when you have a number out in front, you can just divide. If it divides perfectly, you can just divide that by the index, the degree. Good? All right, so the cubed root of 8, the cubed root of -8 is the cubed root of -2 times -2 times -2. Remember, because there's an odd number, so -2 times -2 becomes +4 times -2 becomes +8. Good? And then we have the cubed root of x to the 12th. And if we divide that, it'll just be 12 times 3 is 4, or you can put out 12 x's and put them into groups of 3. See how many groups you get? I was putting them in groups of 4. 1, 2, 3, 4. Right? That would be x to the 4th, which is the same as 12 divided by 3. So that becomes -2. That becomes x to the 4th. And then same thing with y. So we have the cubed root of y to the 12th. I'll try to group them better this time. I need 12 y's. Right? And then groups of 3 only. 1, 2, 3, 4. Y to the 4th. So our final answer is -2 x to the 4th, y to the 4th. Take 12 divided by that 3, or count out 12, put them into groups of 3, end up with 4. Good? All right. Number 15, y to the 7th. Again, if there's no index up here, we just imagine a 2. So you can say it's y to the power of 7 divided by 2, which is 6 divided by 2 is 3, right? So that's y to the 3rd with one y remaining under it, right? Or you can put all 7 out there. Put them into groups of 2. You'll get 3, and you'll have that 1 left over. 7 divided by 2 is 3 with 1 left over. Or you can make 3 groups of 2 and have 1 left over. Good. So the square root of 320. 320 is probably 32 and 10, right? 10 is 5 and 2. 32 is it 8 and 4? Mm-hmm. And then, so 320 is 32 times 10, or 8 times 4 times 5 times 2. 8 becomes 4 times 2. 4 becomes 2 times 2. 5 remains 5, and 2 remains 2. Good. And one more just to get that 4 down to its prime factorization. 4 becomes 2 times 2. 2 is 2. 5 is 5, and 2 is 2. So 320 is 2 times 2 times 2 times 2 times 2 times 2 times 5. It's a second root, right? The index of 2. So I have how many groups of 2? 3 groups of 2. So I can take those out. So it's 8 square root 5 is how I would do it. Or you can find a different way, right? 320 divided by 5 is 64. The square root of 64 is 8. So that would be a faster way to do it. Good. So the 320 becomes 8 squared root of 5. What about x to the 7th? X to the 7th can be x. Oh, sorry. The square root of x to the 7th can be x to the 7 divided by 2, which is x to the 3rd square root x, because 7 divided by 2 is 3 with 1 remaining. Or you can put 7x's under here. Group them by 2. Have 1 left over, right? 3 outside, 1 inside. And then y to the 8th. So y, 8 divided by 2 is just y to the 4th, or 8 y's. Put them into groups of 2. And you get 4 groups of 2. So our final answer is 8 x to the 3rd, y to the 4th, right? 8 times x to the 3rd times y to the 4th times the square root of 5x. So I'm just collecting everything that was still under the radical, everything that made it outside the radical, outside the radical. Now we're going to add and subtract like radicals. You can only add and subtract if they're exactly the same. So they have to have the same root with the same radicand, okay? So you can try simplifying the radicals before you add and subtract them. And then for multiplying, you would need the same root for multiplication and division to be valid, all right? Don't multiply the coefficients with the radicands, okay? So add or subtract, assume all variables represent positive real numbers. 2 times the third root of 3 plus 8 times the third root of 3. You just get to say, well, this is 2 of that and 8 of that, 2 and 8. Third roots of 3 is 10 third roots of 3. Good. Here we have the square root of 3 minus 12 square root of 3 plus 4 square root of 3. How many is this? This is 1. So we have 1 minus 12 plus 4. 1 minus 12 plus 4 square roots of 3. 1 minus 12 is 11 plus, or sorry, negative 11 plus 4 is negative 7. So negative 7 square root of 3. Good. 25 square root of 2 plus 6 square root of 18. 5 plus 6. Wait, no, right? Because for these, they have to be exactly the same. Same number right here, same number right here if you want to combine them. So instead, you want to simplify the bigger one. See if you can't make it a square root of 2 instead of a square root of 18. All right, so let's try that. We're starting out with the square root of 18, seeing how far we can simplify it. Sorry, I don't like it when I put the square root in with the... All right, 18 is just 9 times 2, right? 9 is 3 times 3. 2 remains 2 because that's in its simplest form. 18 is 9 times 2. 18 is also 3 times 3 times 2. So the square root of 18 is equal to the square root of 3 times 3 times 2. The 3's come out, so that's 3 square root 2. Good. That was just the square root of 18, right? So now I have 5 square root 2 plus 6, 3 square root 2. The square root of 18 has now become the 3 square root 2. What I need to do now is these two are being multiplied because they're right next to each other, right? So now I need to multiply the 6 times the 3. 5 square root of 2 stays the same. 6 times 3 is 18, so that's now 18 square root of 2. We got 18, the 18 under the radical, into 3 square root of 2 but there was always that 6 in front of it, so that 3, whatever made it out of the radical, needs to be multiplied with whatever was there first. 3 times 6 is 18. Good. And now we can add them together. 18 plus 5 is 23, square root of 2. Good. Okay. Here we have the square root of 2, the square root of 72, and the square root of 32. Obviously, I can't make this, I can't simplify this at all. Can I simplify 72? 72 is 8 times 9, right? 8 is 4 times 2, 9 is 3 times 3, right? 72 becomes 8 times 9. 72 becomes 4 times 2 times 3 times 3. Let's see if we can get it even simpler. 4 is 2 times 2. Bring that 2 down. Bring that 3 down. Bring that 3 down. And I can say the square root of 72 is the same as the square root of 2 times 2 times 2 times 3 times 3. See what I can take out? That pair and that pair. So that becomes 2 times 3 square root 2, which is 6 square root 2, right? Square root of 74 becomes 6 square root of 2. Remember, we have to multiply it by that 4 that was there before. 6 times the square root of 2 minus, and then can we get 32 factored any smaller? 32 is just, what's 32 divided by 4? It's 8 and 4, right? 8 is 4 times 2. Here, I could turn 4 into 2 times 2, but I want pairs, right? So I could just stop there, and I could say the square root of 32 is the same as the square root of 4 times 4 times 2, which is 4 square root 2, right? Because I would take these out. Good. So now that's negative 2 times 4 square root 2 instead of the 32. The square root of 32 becomes 4 square root of 2. The square root of 72 is 6 square root of 2. Let's simplify this. We've got the square root of 2 plus 4 times 6 is 24 square root 2 minus 2 times 4 is 8 square root 2. And that's just 1, right? There's just one of those. 1 plus 24 is 25 square root 2 minus 8 square root 2. And so that will be 17 square root 2 is our final answer. Good. All right, simplify the expressions and assume that all variables are positive when they appear. Okay, so we've got the cubed root of 14 times the cubed root of 4. You can check to make sure you can't take anything out of this, right? Is there any way that you can simplify this cubed root of 14? There is not, because 14 is just 7 times 2, right? 4 is just 2 times 2. Neither of those are perfect cubes, we call them. Okay, so now you can just multiply. 14 times 4 is 56, so this all becomes the cubed root of 56, but you're not quite done yet. You want to make sure you can't simplify the 56, okay? And just divide it by whatever you can think of. 56 divided by 8, right? 56 divided by 8 is 7. 8 is 4 times 2. 7 just stays as 7. This is 2. 4 is 2 times 2. Good. So we have 2 times 2 times 2 times 7 instead of 56. So the cubed root of 56 becomes the cubed root of 2 times 2 times 2 times 7. The group of 3 2's can come out. We're looking at groups of 3. And so you get 2 cubed root 7 is our final answer there. Okay. Here we have 2 square root 7x to the third times 5 square root 7x to the fifth. Let's try to simplify this first, okay? So 7x x to the third just looks like this, right? We can take out a pair of those x's. And now we have x square root 7x, right? Bring it back to that 2. 2 times x square root 7x times, over here, square root of 7x to the 5th. That means we have 5 x's. One, two groups. X times 7x, which is just x squared, square root 7x. Okay, let's simplify that by combining the terms outside, or the coefficients that are, excuse me, outside the radical, okay? So we're going to find 2 and x to get 2x. Square root 7x times 5 and x squared. Times 7x. Good? Now we're going to multiply. Multiply the coefficients with the other coefficient. I'll find a different color. So multiply the 2x with the 5x squared. Okay? 2x and 5x squared become 10x to the third, right? And then multiply the square root of 7x times the square root of 7x. So we put them all under the radical and we multiply them. Now, what do you see when we just list them under the radical? We have a pair of 7s and a pair of x's, right? If we have a pair of them, that means we can move them out. 7 times x times x. That comes out. And that comes out, right? To get 7x outside the radical. So now we have 10x to the third times 7x. Good? Equals 10 times 7 is 70. X to the third times x is x to the fourth. We're just adding them together. Good? 70x to the fourth is our final answer for this one. You didn't need to simplify it first, right? You could have just put all of that under the radical, but I like to get things out from under the radical first so that I don't have such a big number under here. But you can just go 2 times 5 is 10. Everything else is under the radical. 7 times 7 is 49. X to the third times x to the fifth is x to the eighth, which comes out to be 7x to the fourth, and take it out. You can do that too. All right, 24 is the square root of 3 times the square root of 5, the quantity square root of 5 times square root of 7. We're going to distribute the square root of 3. Just like we were distributing in a monomial times a binomial, right? Rewrite it as the square root of 3 times 5 plus the square root of 3 times 7. So that's the square root of 15 plus the square root of 21. And you can't really simplify 15, square root of 15. You can't really simplify the square root of 21, so you are done. Here we're going to distribute a 5. So now we've got the square root of 5 times 35. I'm going to skip that step and just put them both under the radical. Minus 4 times the square root of 5 times 5. Good? Okay. So here I see already that this is a pair, so it can come out. So now we've got the square root of 5 times 35. You can multiply it or not, because we're just going to break it into factored form, right? We're going to factor it anyway, so you don't have to multiply it. Minus 4 times 5, which is just 20, right? So the square root of 175 175, and we saw that it grouped to 5 and 35, right? 5 is prime, so we don't have to go any further. We just 5. 35 is 5 times 7, right? So 175 is 5 times 5 times 7. 5 times 5 times 7 is 5 square root 7. You're welcome to put that into your calculator to make sure this gives you the same number as this and that. Yeah? So that becomes 5 square root 7 minus 20. Good. And you can change the order if you want. You can't combine those. Negative 20 plus 5 square root 7. You can't combine them. You can just leave them like that. Good. Okay. Now we're going to deal with radicals within fractions. What you need to do is rationalize the denominator and assume that all variables are positive when they appear. So multiply the numerator and the denominator by the denominator to get rid of the radical under there, okay? So 6 divided by the square root of 5. I don't like that there's a square root of 5 in my denominator, so I'm just going to multiply both the top and the bottom of the fraction by that denominator. So now I have 6 square root of 5 divided by square root of 5 times 5, which is 5, right? That's a pair of 5, so I can pull them out. So that's all we need to do. We just simplified it to 6 square root of 5 divided by 5. We're done. Okay? Same thing down here. Negative 9 divided by the square root of 20. I don't want that radical in my denominator, so I'm going to multiply both the top and the bottom of the fraction by that number. Negative 9 times square root of 20 is negative 9 square root 20 divided by square root of 20 times the square root of 20 is just 20. Good. All right, 28. Remember, a to the power of m divided by n is equal to the radicand of a raised to the power of m with an index of n, okay? You can take the root first. It will make smaller numbers to work with. Okay, so you want to write the expression and simplify as possible as a radical. So 8 4 over 3 becomes, so we're going to add the radical sign. We're going to keep that same 8 right here. Now look, the bottom of it, the denominator becomes the index, okay? So the bottom of it goes right there. The top of it becomes your power. Good. So we rewrote it. 8 to the power of 4 divided by 3 is the third root of 8 to the power of 4. 8 to the power of 4 is 8 4 times, right? If you have a group of 3, you can take it out. So that's just going to be 8 times the cubed root of 8. Sorry, I didn't notice that the cubed root of 8 is also a. You can keep going with 8, right? We've done this a few times today. 8 becomes 4 times 2. 4 becomes 2 times 2 times 2, right? So 4 times 2 is 8. 2 times 2 times 2 is 8. So now we have 8 is the cubed root of 8 times 8. Or sorry. We have 8 times the cubed root of 2 times 2 times 2. Didn't take this far enough. The 3 2's come out and we just have 8 times 2, which is 16. That was a tricky one. So number 29 is actually 16 because the cubed root of 8 is 2. 2 times 8 is 16. Cubed root of 8 is 2. You can also just say 8 to the power of 4 divided by 3. I'll give you the right answer. You can also put in the cubed root of 8 to the power of 4. It'll give you the right answer. Sorry, that glare is bad. All right, 30 needs more space now. Negative 32, 1/5 becomes, right? So we draw that radical. Negative 32 goes under here. The bottom number goes right here. So I'm going to need 5 of the same thing, and the top number goes right here. Negative 32 to the power of 1 is just negative 32. So what is the fifth root of negative 32? Remember, you don't have to stop because this is an odd number, so odd numbers can have negatives in as the radicand, okay? Can we factor 32 to anything that would be something times itself 5 times? 32 is 16 and 2, right? 16 is 8 times 2. 8 is 4 and 2. 4 is 2 times 2. All right, so 32 is 16 times 2. 32 is also 2 times 8 times 2. 32 is also 2 times 4 times 2 times 2. 32 is also 2 times 2 times 2 times 2 times 2. Good? So that's going to be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And you can check that. Negative 2 to the power of 5. Negative 2 5 times is negative 32. Good. And we needed 5 of them. 1, 2, 3, 4, 5. So that's just going to be negative 2. They can all come out. Good. So the answer to this is negative 2. 5 times x to the 2/3. Remember that the exponent is only related to the number it's closest to unless they're in parentheses. So we're just doing 5 times x. Take that bottom number. Sorry, that bottom number, put it right here. Take the top number, put it right there. 5 times the cubed root of x squared. Can I simplify that? I cannot. So it's just 5 times the cubed root of x squared. Three x times power of 2/5. Now we have the parentheses. So now that 2/5 goes to both the 3 and the x. So we have 3x to the power of 2/5. We draw the radical, we put that same base in, 3x. Take that bottom number, put it here. Take that top number, put it here for both of them, okay? So that becomes the fifth root of 3 squared is 9, x squared is x squared. So it's the fifth root of 9x squared. I don't think we can simplify that any further. Oh no. Just have to write it really big because I was copying it down, thinking that was a bigger number. All right, write using rational expressions. So here we wrote it as a radical. Now they've given us the radical and they want us to write it as a rational expression. Good. Okay, so we've got x and y. Here, I'm going to rewrite the equation. So we have a, right? M in the numerator becomes the exponent in the denominator, in the radical form. And then n becomes the index. Good. So here we have 3 that goes on the bottom of the fraction, and then the exponent goes on the top of the fraction. There is no number here, so we just assume it's a 1. So it's xy to the power of 1/3. Good. Number 34, we have the square root of x to the 4th, y to the 5th. So again, We're starting here, we're going here. So what's our base? Our base is, we have two different ones. We have the base of x, right? M goes on top, so 4. And then the n goes on the bottom. The n is an understood 2. For y, the m goes on the top, the 5 goes on the top, the n goes on the bottom. Good. So I'm going to rewrite it. X to the power of 4 over 2 times y to the power of 5 over 2. I can simplify that. 4 divided by 2 is 2. 5 divided by 2 is 2 with 1 remaining. Okay? So that is my answer for number 34. And I think those are all the examples we're going to work on for this lesson. Thank you guys so much and have a wonderful day.